Welcome to the sixth section of Hands-on Continuous Integration and Automation with Jenkins. In this section, we are going to explore how to integrate Jenkins with Amazon Web Services. In particular, we will briefly introduce Amazon Web Services and the AWS resources we are going to use in the practical part. We will also look at the master-slave architecture in Jenkins. In the practical part, we will install Jenkins on AWS and set up a Jenkins build farm. Let's start with an overview of what we are going to cover and build together in this section. In this video, we will introduce Amazon Web Services, explain the master-slave architecture in Jenkins, and give a preview of what we are going to build in the next videos. There is no practical part in this video, but we will introduce key concepts that we are going to use in the demo for the next videos. Let's start by introducing Amazon Web Services. AWS is a cloud computing provider selling on-demand computing resources like servers, storage, etc. AWS, and cloud computing in general, allow to spin up a new server within minutes and to decommission it when it's not needed anymore. This makes cloud computing very appealing because computing resources are built by usage and no upfront investment cost is required to purchase a server. You can think of cloud computing as renting computing resources rather than buying them. AWS is not the only cloud computing provider. Other popular ones are Microsoft Azure, Google Cloud Platform, IBM Cloud, etc. But AWS is the market leader and probably the most popular cloud computing provider at the time this video was shot. To follow the practical part in this section, you need to sign up for an AWS account. You can sign up at the following URL. Do it before watching the next video, as we will not cover this in the demo. Signing up to AWS for the first time entitles you to a free tier. This means that you can use some basic AWS resources for up to 12 months without paying. Have a read through the AWS free tier to discover which computing resources can be used without incurring costs. However, I need to warn you about few things before we proceed with AWS. Registration to AWS requires a credit card, even if you don't go over the free tier. The practical part in this section will use AWS resources within the free tier. However, your credit card is going to be billed if you exceed the resources in the free tier. For example, if you spin up a server with higher specs, or if you keep it running after the free tier period. You can monitor AWS costs via the billing console, and I will show you how to access it in the next videos. I recommend to keep an eye on the billing console to avoid any surprise. In general, it is a good saving strategy to stop or terminate the AWS resources when you don't use them. Remember that you are billed by usage. Finally, I have to warn you that you undertake the practical part of this section entirely at your own risk, and I cannot be held responsible for costs or misconfiguration. But I don't want to scare you. If you follow the instruction, you will learn something useful and you will not incur any cost. Okay, enough with money warnings, let's move to something technical. We are going to deploy Jenkins on AWS using a master-slave architecture. This is also called master agent or master worker architecture. Let's see how it works. Until now, we have used Jenkins on a single master node. However, as the number of Jenkins users in a team increases and more jobs are executed by more users, Jenkins performances may degrade due to higher CPU and memory requirements or lack of disk space. It is possible to run Jenkins on a higher spec machine, but a better approach is to deploy it in a master-slave architecture and offload jobs to slave nodes. In such a configuration, you have a Jenkins master and several Jenkins slaves, also called agents or workers. The Jenkins master becomes a scheduler and distributes the builds across the slave nodes. For example, it sends the first job to the first slave, the second job to the next available slave, and so on. The master-slave configuration allows to distribute the builds, and this has several advantages. In terms of flexibility, the slave nodes can be customized to run specific jobs, for example, build and test on a specific browser or operating system. In terms of resilience, the performance on the master node is improved as long-running and resource-consuming jobs are sent to slave nodes. Plus, even if a slave node fails, jobs running on the other nodes are not affected. The major advantage is scalability. In fact, slave nodes free resources from the master node, allow to run jobs in parallel, thus sharing the load across multiple machines, and scale automatically since the number of slave nodes is increased at peak build times and decreased during low activity times. Deploying Jenkins in a master-slave configuration usually falls into one of these two deployment strategies: a single large master with multiple slave nodes connected to it, that's the configuration on the left, or multiple smaller masters with multiple slave nodes connected to each other, that's the configuration on the right. Both deployment strategies are valid and fulfill different purposes. For example, a single master configuration is easier to maintain and is well suited for a single team. The multi-master configuration is more robust and is better suited for multiple teams. For sake of simplicity, in the practical part of this section, we're going to deploy a single master architecture. This diagram shows what we are going to build in the practical part of this section. We will deploy Jenkins in a master-slave architecture on AWS. This is a professional and secure setup that you could use at work for your team and is accessible from a stable IP address. We will mainly follow the official documentation in this link to deploy Jenkins on AWS. Don't worry if you have never used AWS before. As we set up the Jenkins build farm, I will also introduce some of the AWS jargon that you can see in this diagram, things like VPC, EC2, etc. This is the end of this video, where we described the master-slave architecture and had an overview of what we are going to build in this section.